Right, so what we're going to do is we're going to make a scatter graph using Microsoft Excel. So what I've done, I've created two columns here. One is the fertilizer added, and here is the plant height. And you can see the more fertilizer we add, the greater the plant height. So in one case, I only added 1 milliliter of fertilizer. I only got a 3 centimeter high plant. Whereas if I've got another case here, if I add 18 milliliters of fertilizer, you can see the plant height is notably higher. One of the things that we have to appreciate is that it's the fertilizer that affects the plant height. The fertilizer, because this affects this will go on our independent variable, our horizontal axis. Okay, this is our explanatory variable, and this is our response variable. This goes on the vertical axis. So what we're going to do is we're going to highlight this data here. We're going to go insert, oops daisy, no, insert scatter graph. Okay, now if I just zoom out slightly, what I'm going to do is I'm going to insert the axis titles. So we can see our vertical axis here was plant height. So if I type in here, okay, and this here was fertilizer added. Okay, so now we've done this. What we're now just going to move it off to one side. Now what I'm going to do is we're going to add the line of least squares regression. To do this, if we press add, and then we select trend line, so we go trend line, more options, so now we go down to more options. Okay, and now what we do is we scroll on down. Since we're in year 10, we're just going to leave it as linear. We're not going to do any of this logarithmics. And we're going to select here, display equation on chart. So we do this. Now, when we just close this down, this equation, what does it mean? It means this is the line of best fit, or the line of least squares regression. What we can deduce from this is for every 1 milliliter of fertilizer we add, our plants will be 0.8278 centimeters higher. If we don't add any fertilizer at all, our plant will be should be approximately 1.6 centimeters high. You can see that this line of least squares regression, our line of best fit, shows that we've got positive correlation. It's a line that fits in between all the data. Okay, showing positive correlation. If the points closer to the line, then that would show stronger correlation. If the points are further away from the line, then we've got weaker correlation.